Hi, good afternoon. This is Patrick O'Shea from NYSERDA, and this is Buildings of Excellence, Case Studies and Elevated Expectations. And joining me are Victor and Stash, and I'll be leading off with a presentation on New York's carbon neutral buildings and the genesis for Buildings of Excellence. I am the Director of Market Development for NYSERDA. I focus on the commercial and industrial areas, as well as new construction and energy codes. And at NYSERDA, our new construction programs, which sponsor the Buildings of Excellence, work together with our energy codes team so that as we develop concepts and help bring them to market with our market partners and design teams, we are capturing that learning into future rounds of energy code. One of the things that guides our policy is New York's climate legislation and long-term climate objectives. The most significant one of these is our objective to have a carbon neutral economy by 2050. And a key point of that carbon neutral economy by 2050 is to achieve carbon neutral building stock statewide by mid-century. In general, we look at carbon neutral buildings as buildings that generate no carbon emissions in their operation. We are beginning to look at embodied carbon, but fully incorporated into our objectives is the emissions footprint of the buildings as they operate. As you may also be aware, New York State has a goal to convert the electric grid to 100% renewable by 2040. And so buildings that were primarily electric and grid connected would also achieve carbon neutral emissions at that same time. So currently, we have a little bit of a ways to go. Currently, 0.5% of the buildings in New York are net zero buildings. And just to give you a thumbnail sketch of New York State, we have about 4 million single family homes. And we have about 780,000 commercial buildings, which includes multifamily buildings. Multifamily buildings, in terms of units, we have about 3 million units. So, and when you look at our existing building stock, that is our fundamental challenge, but we look at new construction as being a pathfinder or leader to find and prove that technologies work and to get scale. But ultimately, we're going to apply what we learn in new buildings to existing buildings. The carbon neutral building roadmap is our first attempt to create a overall plan for the state. And it will start off by identifying pathways. And we've picked some building types, which I'll talk about, to start the pathway. We're also looking at critical building decarbonization issues. And as I've mentioned, embodied carbon, that's an area where we have much work to do, and we will be incorporating it as we move forward in the roadmap. We do engage stakeholders. So far, we've had more than 20 stakeholder input sessions to give us input into the development of the roadmap. And as we finish our first draft of the roadmap, we plan on going out with a roadshow later this year to share the roadmap and the key learnings. And our goal is to present the roadmap to the Climate Action Council to drive New York State policy early in 2021. The roadmap scope, in terms of what we're looking at, it includes new construction, as I mentioned, and existing buildings. We are looking at a shift from net zero buildings to carbon neutrality and what that means. So we're figuring that out. And we've picked multiple sectors to start with. We picked single family homes, multifamily buildings, mid-rise and low-rise office space, and within higher education, we picked classrooms and dormitories. We picked these sectors for a couple of reasons. They represent significant portions of the existing and new construction building stock. And also, we believe that they are building typologies where carbon neutrality is both technically and economically possible at this time. So they make good starting points. One example of an area where we have work to do is super tall buildings, so skyscrapers. They're very complex, and we still have significant technology and economic issues to move skyscrapers, which are, as you know, are a dominant building type in New York City, to carbon neutral. So we'll begin research and identification of the issues, and we'll be incorporating pathways for skyscrapers in future editions of the building roadmap. New York's construction market, and this is a backwards view averaging out the last 4 to 5 years. We have about 100 million square feet of new construction per year. 40% of that is multifamily. We have a large affordable housing priority. We have a shortage of affordable housing, specifically in the Metro New York City area. 80% of our multifamily buildings are in New York City, and about 2/3 of those serve low-income communities. We have a very different market between upstate and downstate. Upstate, where land is relatively inexpensive, you will see low-rise multifamily units being the primary form of construction. And then downstate, you will see a mix of high-rise and mid-rise, and in certain areas, mixed-use buildings where you have retail and other types of tenants on the bottom floors, and then housing on the top floors. So it's a very different market depending on which part of the state you're on. Given that multifamily buildings were such a large portion of the new construction market, and given that we could prove not just that carbon neutrality was possible, but what it meant for people to live in a carbon neutral building, we decided in the Buildings of Excellence competition to focus on the multifamily space. So this is an example of a project in upstate, 4-story unit. This project incorporated PV solar and solar thermal, along with heat pumps and instantaneous hot water. The cost, at least in upstate, for a net zero building or carbon neutral building are in the 0 to 3% range. Not for your first project, but more like for your third or fourth project. There is a learning curve, but teams have shown a way to get costs down and improve the mix of technologies that they're using. So that happens to be a project right near Albany. We have been investing in this area for many years, working with partners to improve our focus in terms of what we're investing in, and the construction methods that the market has been using have been improving. So it's not just incorporation of renewable technologies, but we've made significant improvement in the building shells, and that's one of the key areas upstate where the heat load is such an important part of the building. Downstate, we've had more challenges with mid and high-rise buildings. The technologies are pushed in some cases to their limits. Projects are more expensive to begin with, so there's more risk associated with moving down the learning curve. We are using third-party standards, and we do performance evaluation. So we validate the results to make sure that the results that people are claiming are actually being achieved. One of the things in our Buildings of Excellence competition that's really important is that we are evaluating the results of our partners. We're tracking the technologies. We're looking at the costs in comparison to traditional construction, and we're sharing that information with the market. So in the area of lesson learned and applying what has been done in other industries of construction, here are some of the things that we've learned. We've learned the value of panelized exteriors with air source heat pumps. We've seen a growth in modular projects, mostly in low-rise and mid-rise. We're looking at low greenhouse potential refrigerants and low embodied carbon. We've actually begun to see some high-pressure carbon dioxide systems in some of the Buildings of Excellence competition winners. We're launching a new program to focus on net zero urban infills, and that would be one of the areas where we see growth for modular. And then we're developing measure packages of bundled measures so that we can focus on getting scale for provable packages of low emission, low energy performance. And that is all I have, and I'd like to turn it over at this point to Victor. and thank you.
Thank you, Patrick. Appreciate the intro. So my name is Victor Malerba Jr. I work at Architectonica, and we're going to talk about one of our projects we did here in New York City. But first, a little background on Architectonica. We're an architecture, master planning, programming, interior design, and landscape architecture firm. The firm was established in Miami in 1977. We have over 650 plus staff, 9 offices worldwide, won over 430 National Design Awards, NYSERDA, Building of Excellence being one, which we're very proud of. And we're a large architecture firm, one of the largest in the world, and we have a big building approach to a lot of our projects. We do anything from usually 200,000 square feet to up to 1 million square feet of buildings. We built approximately, probably at this point, over 250 million square feet of building space, 500 plus pod projects, and then over 50 countries. Here are some of the countries where we built some of our projects, and there are locations of our office worldwide. I am located in the New York office, and the project we're going to discuss is in New York as well. We work with some of the leading residential developers, I would say, in the world. Here is just a list. The majority of our projects, I would say about 80%, are repeat clients. We are a developer's architect. We do very efficient buildings, but also very highly designed buildings with different aspects to them. As we see in this building, it's very unique. It's a one-off, but also we try to incorporate typical building technologies into each building, not just make it very unique, but also make it very special, but also make it very buildable. We are one of the domestic leaders in residential development. Here in the US, we have projects probably in most every state. Here are just the highlight of some, and from California to Nevada to Ohio, Massachusetts, several in New York, Miami. I was once told, because our headquarters in Miami, that you can't throw a rock in Miami without hitting an Architectonica building. Very popular architect in Miami. And a little personal background on myself. I am been 8 years now with Architectonica. I work on a lot of mixed-use buildings, residential, hospitality. I am new, although I've always tried to do a very energy-efficient building. Usually we're tasked with buildings being very efficient and very economical. So it's hard to really get that building, but this is going to be one of the buildings we're going to talk about today. Is one that we're very proud of here in this office and Architectonica. It is a residential tower in New York City. It is a passive house design and is a NYSERDA Building of Excellence winner. But with every project, it's very important to have a good project team. Here are some of our team members, from ownership to project management to the architects internally, to engineering, to our passive house and envelope consultant, to our contractor. Most people will forget about the contractor, but as far as you're doing a very efficient building and very high end, you always have to have a good contractor to really build the building. I mean, at the end of the day, he's a valuable, or she is a valuable team member that can't be discounted. And it's very important when we do hand off those drawings that they're in capable hands. The success of every project is a direct relation of the project team. From owners, designers, and contractors, each member of the team has to have their project goal in mind. If not, it doesn't work. From the design drawings, making sure the QA/QC and design drawings are very tight and very coordinated, to the QA/QC in the field. It's very important. Now, the project we're going to talk about today is located at 511 East 86th Street in New York City, close to the intersection of 86th and York. Here we see a 3D view of the urban environment. It's on the Upper East Side of Manhattan. It's a dense urban environment with several surrounding towers and a park to the east, and then UQ line, the Second Avenue extension, 2 avenues over to the west. It's a typical urban environment. Something we typically see in this office, something we typically see as architects. The survey of the site, it was 3 former separate lots with low-rise, inefficient buildings on them. The owner approached us to combine these 3 lots and make a tower. As we started the project, the owner actually purchased the orange lot you see here, so it created an interesting dilemma for us. This additional lot, although we always welcome more project or more scope, is a sliver building lot. So when we first started designing this tower, it was on these existing lots, and we always designed from the inside out. typical massing extrusion. We usually start with New York City zoning. And what the New York City zoning told us about this lot, it could be 230 feet high above the base plane, has mandatory quality housing, and optional bonus 2 FAR for inclusionary housing. This is the first hardline approach we did at the project, very, very early. You notice here, the original scope is not including that little L. When we added this lot, we tried to keep the centralized core where it is right now. And as you see, as we go through the plans, it really didn't move too much. As we were in conceptual phase of this project, we start to list all the requirements. As we start to draw, what are the requirements for the project? And here are a few. We have the United States Access Board, New York City Building Code, New York City Planning, Multiple Dwelling Law, contract. And as we started going through it, the owner started piling on more items to do and more items to include, and included passive house. So although we never did a passive house project in this office, we're familiar with passive house standards. And also, we also noted that we want to go for a NYSERDA Building of Excellence competition. And also what he added, as you can see, New York City Department of Finance on the left, he also added that we want to go for 421A tax program, which then triggers UFAS units, HPD requirements for affordable units. So all this piled into the building, and our office needs to educate us. We needed to educate ourselves on passive house. So what's the first thing I did? I took a walk over to the Strand bookstore in Manhattan, and I bought a couple of books. Several of us got passive house certified. I wasn't so lucky, so I had to do it from a book. And this is what was the yield of the project. Not taking through all the design process, which took months, almost 2 years from start to finish. This is the result. Here we have a typical tower plan and a typical tower axon. As you can see, the core is centrally located to make sure the floor plate is very efficient. As you know, real estate in New York is very expensive, so every inch is rentable. And a typical tower upper plan with our facade undulating, and you can start to see where the zoning setbacks come into play and where we start to implement dormer law, which allows you to articulate the facade in a certain way to make it a little interesting. So it's not a real start and stop from the base of the tower to the up portion of the tower. Getting into the program a little bit, our cellar level, which included some amenity space for the residents, which was needed to be included for quality housing. We have a media room, a kids' playroom, and also a pet spa. So any occupant of the building has a pet can come down here and wash their pet. As we can see in some of our buildings, the amenities are getting more and more specific and more interesting. The ground floor, which is our building entry, houses our entry lobby, our mailbox area, our concierge desk. And we did something interesting here. Since the core is located centrally, instead of creating, and it is very tight footprint, instead of creating the concierge desk more towards the front of the building, we opted to wrap around the core and have the elevator ladder on the back side, which created a nice little lounge and also incorporated outdoor yard area with some bike storage, which was mandatory for this project. And here we have some renderings of our interior lobby. Unfortunately, this project is still in construction, so I don't have any final shots, but I'm hoping they look like this. As you see here, as you enter, we have a marquee wall, and then you wrap around the back to get the elevators. So you don't see where the elevators are. They're hidden in the back, and creates a little nice kind of living room feel to this building as you enter. Very homely, especially because it's a residential building. And behind those elevators, the elevators on this slide will be behind the bookshelf to the left. We created another lounge area, which gives occupants a place to sit and repose, and also opens up to the outdoor garden. Our second floor plan houses some of the start of the residential units, and also the reading room, another reading room or slight lounge to the back of the building. Elevator 1 floor connects to a barbecue deck, where residents can barbecue, and also our fitness room. We locate these at the base of the building because usually people want to be higher in New York City to get more views. So this is a perfect opportunity to look at amenities at the lower level. Here's a rendering of the second floor lounge area and reading room. What's interesting here is we start to talk about passive houses. The fireplace originally specified was supposed to be gas, but beginning as combustible, we went with a water vapor. If you haven't seen a water vapor fireplace, I implore you to do so. They're really quite interesting and actually do look like fire. And in the background here, you see the kitchen area where it's a community kitchen. So somebody come down here, maybe host a party or lounge. As we move up through the building, the residential units are pretty typical for floor, but also start to change from 1 bedroom to 2 bedroom and some studios. Here we have a typical tower building, residential units, with somehow balconies off to the front and the back of the building. Here you see the silver building. You can really see how tight that sliver building is. Sliver building law is a lot that's 45 feet or less. This is pretty tight. It's a pretty tight lot, but we made it work with our centralized shear walls for structural stability. On the roof of on the 12th floor, which is the roof of the sliver building, because we're maxed out on height there, we put a dog run where occupants who have pets in the building can allow their dogs to run around here and get some amenity space. Every inch of this building is accounted for, whether it's on the floor plate, on the balconies, or any of the roofs. Most of the roofs here, except for the penthouses that are mechanical, are activated. Here's an typical upper tower plan. As you can see, the centralized core and the scissor stair, which is a lot in New York City for residential, really centralizes and gives the floor plate very high efficiencies, extremely high efficiencies. With the balconies on the front and back, allows for access to tenants to get outside and get the wonderful views in New York City. And speaking of views, the roof plan was almost 100% activated. Really, really tight coordination on this, which we utilized Revit and BIM to coordinate the roof plan. So every little square inch that we can use for recreational space was actually used. And here are some photos that I took at the topping off ceremony. And now you know why. That roof plan is going to have, that roof deck is going to have amazing views to the north and south is through Mount Manhattan. And as we start to look at the building elevations, the materials on these building elevations were really straightforward. The front facade, which is the most visual facing facade, or facades on York and 86th, are porcelain panel with a rain screen system. This allows us to keep our continuous insulation on the exterior of the building and make the building very efficient. It also gives us a hard surface to apply our air vapor barrier to make the building 100% tightly sealed. Here you have some shots of the south elevation, the sliver building elevation with the porcelain panel rain screen facade applied. On the other facades, we applied EIFS. Because of access and because of non-street frontage, EIFS is a very efficient exterior envelope system, which allows for 100% or full, I should say, continuous insulation and air barrier applications. The maximum building height on a building was 230 feet, with setbacks provided for zoning. As you can see here, we start to articulate the facade for setbacks for zoning, but also you don't know there's setbacks for zoning. We didn't want just a dead stop from the lower portion of the tower to the upper portion. We wanted to articulate that with balconies and setbacks. The building envelope facing the streets is well-insulated rain screen system with large porcelain panels offering long-term durability and low maintenance. Walls facing the backyard are covered with highly efficient EIFS system. Large operable windows offer plenty of natural light, fresh air, spacious feel, and connection to the outdoors in all apartments. Tenants will be able to enjoy views of the East River from private balconies and public terraces. One of the defining characteristics of the building is the thermally broken cantilever balconies. This was always a wish list for us architecturally, thermally broken balconies, because there's nothing like standing next to a balcony and having a cold floor, especially on the Upper East, the Northeast coast. Now, as we started to design this building, we started to implement the Passive House requirements. And Passive House is a very interesting standard because it's performance-based. We have prescriptive-based options when designing buildings, but performance-based actually gives us real results. As Patrick was talking about earlier, there's measurable results when you build your building with the Passive House standard because you have to fit a criteria. If one is a little bit lower than the other, you have to decrease the other one. But these are some of the features that are in our building currently, or in our building design and being implemented over this project. The suite of high-performance strategies implemented on this project were developed and evaluated through the iterative design process involving all members of the design team. As you can see here, it's not just architecture, it's MEP, engineering, structure, everybody. The highly insulated and airtight envelope requires Passive House certification, utilizes aerated concrete block for structural and thermal properties, triple panel glazing, and a combination of a liquid applied and air barrier and high performance air sealing tickets. The blower door test was something to be seen. Heating and cooling are provided for all spaces via air source heat pumps VRF system with heat recovery for maximum efficiency. A separate centralized ventilation system circulates fresh air to all living spaces and amenities with over 80% efficiency energy recovery ventilators and demand control with CO2 sensors to increase energy savings. In addition to these elements, Energy Star appliances, LED lights with occupancy controls, and common areas, condensating boilers, all contribute to state-of-the-art low energy building. Some of the things I want to focus on here are architecturally, things I was really headhunted or spearheaded, I should say, on this project was the envelope. These are some raw typical details on the envelope, because architecturally, these are where all our bread and butter is, and making sure the building is sealed. When we talk about MEP systems, we're really relying on our MEP engineers to make sure the systems are accurate and work properly. Here we have a typical window head detail with our continuous air barrier and continuous insulation. As you can see, this detail, although simple to draw, is very hard to fabricate. That's why contract is very important to having this job perform well. Another typical detail is our EFIS system. Again, it's a very typical detail found in architecture, but it needs to be installed properly. Here we have a AAC block, a continuous air barrier, a drainage system at the air barrier, XPS insulation, and our finished scope. Here's where the details get a little interesting, for me especially, is how do you continue that air barrier or that waterproofing membrane to wrap and continue? And also, if everything connected to the deck, how do you block it? So what we did is we actually used insulated blocks or elastofoam insulated blocks, which are structural foam blocks that actually create a thermal break with anything mounted to the slab, so you don't have that thermal conductivity. Interesting detail, very simplified here, but took a lot of time to work through. Another detail here is a window head detail to the roof, which shows our continuous insulation wrapping the coping and continuing down. Again, there's another simple detail, but it took a lot of effort to do, as all these elements need to work together and be in sequence and installed properly. Here's one of our more interesting details with our thermally broken balcony. Since we did this project with thermally broken balconies, I tried to do this on probably every project with a balcony since, and it always gets VE'd out. I'm glad we were able to do it here and make it work. And hopefully when we start getting performance criteria for this project, we'll start to implement them more and more. Here we see our triple glazed terrace door, our elastofoam insulation block to support that door. Basically a thermally broken shock isocore thermally broken balcony connected there, with also a head detail and insulation. And don't forget our continuous air barrier. Here are some of our products that we used on a project that were not new to us, but we always want to implement. It seems like we threw everything at this project because it was passive house. It needed to be highly energy efficient. Our structurally thermal isolation blocks, which I'll probably use in every project now since. Our AAC blocks, which is a highly R-value block. Structural thermal breaks, thermally broken facade girts, triple pane windows, and our air barrier. What does this all mean? If we can't quantify for the DOB, the New York City DOB to evaluate and approve, and also for NYSERDA to review and approve, this is our comm check sheet. Very simple comm check. I actually had the team run this comm check probably 4 times, because every time it spit out the numbers, I couldn't believe the values here. I believe this building was like 40% higher than the actual energy code required for New York City at the time of design and submission to DOP. Really, really, really interesting stuff. As we get closer to energy codes being more stringent, that number decreases, but for this type of building and these construction methods, it's really nothing to worry about compliance. You just have to show it. So here for me is where the rubber meets the road. Here's a rendering for May of 2016, and here's a project of May of this year. The rendering really captures the design essence, but also the project was implemented almost to the T with the rendering. And this is how we measured the success of a project. I think it's a Curbed website, forgive me if I misquote that, does the comparison from rendering to real life. And I think this one is something actually we'd send them because it actually came out pretty well designed, pretty well executed. Another rendering of the facade, rendering done on May 5th, 2016, and a picture taken May 22nd of 2020. As you can see here, the execution was pretty spot on. From the very inception of the project, the ownership team had very few fundamental ideas that influenced every aspect of the design. They wanted to create a building that would provide a healthy and comfortable environment for its tenants and owners, while drastically reducing energy bills and creating profitable investment far into the future. The 515 East 86th Street project is a 140 unit, 140,000 square foot apartment building under construction in the Upper East Side of New York City that is designed to pass our standards, and also was submitted and won the Building of Excellence Award from NYSERDA. Using integrated project delivery along with passive design principles and efficient mechanical systems, the project will achieve significant energy savings and high occupant comfort with overcoming inherent design hurdles, all without compromising the architectural design intent. And the renderings really prove that, and the award really proves that this building is state-of-the-art, but also can be easily repeatable and designed to a high standard. Thank you very much, and now I pass the presentation over to Stash.
Thank you, Victor, for that great presentation. So my name is Stashzakszewski from Z+H Architects. I'm a principal here at the firm, and I'm going to be giving a little bit of background first on our firm, where we're coming from, and some of our projects before I dive into this Buildings of Excellence project. So our firm was founded in the year 2000, and we really focus on a lot of different ranges of building typologies. We started with smaller building additions, and this is one in downtown New York, in addition to an existing loft building, up to a medium-sized project, which is this new building that we built in the Hudson Square area. And we're often brought in to customize different projects, do interiors, renovations. So this is the Lucky Rice Pavilion. It is a mass timber project that we built last year. It's all prefabricated, made in small components, and it's showcasing the importance of rice in our world. And all of these component parts of this temporary pavilion have been taken apart and then brought to New York City schools in the area and reused and recycled. So I talk about some of the different ranges of sizes of our projects. We've also worked at a much larger scale, the urban design of the city, and this is a project that we won an honor award from the AIA on a competition that we won for reimagining a very large block right beside the West Side Highway. And we were looking to see how we could re-envision a large sanitation garage. So this project is a good kind of starting point to talk about where and why we, as a firm, Z+H Architects, are really interested in these high performance buildings. So this was in 08-09, and as you know, this was a time of recession. It was a crisis. And of course, I had a little bit of extra time on my hands. So I was, at the time, a little bit frustrated with the fact that as architects, we're not always trained to think about the performance of our buildings. It's so much focus on some other aspects which are important, but how is it that our buildings really work? And so I decided to enlist in the Certified Passive House Designer course in 2010, and I really was amazed at how little I felt I knew as an architect about high performance buildings. And it put me on a voyage to really investigate this. And I started to sign up for a lot of these different conferences. I went to Europe a number of times. And we decided to really focus on this in our firm from then on. So a number of us got certified in the firm. And we're really, really fortunate that today we have a number of different scales of projects that are all certified passive houses or close to being certified. And that experience has brought us and led us to this larger building that we're doing. So, for example, at a smaller scale, there's a single family residential building in Ditmas Park in Brooklyn, a condominium at a medium scale. And again, at the large scale, this is Flo Chelsea, which I will be talking about further today. All of these are in various stages of getting certification, either as a new building or as an EnerFit project. An EnerFit is a project which is a renovation of an existing building. And this building was 3 stories, and we completely gutted it and changed it. And it just shows that you can completely rehabilitate some of these existing buildings. So we last year applied with 2 of our potential projects, or sorry, 1 project that was in construction and 1 that was in design. And we were very fortunate to win an award in both projects. So one of them is the Street Smart project, and the other one is Flo Chelsea, which we're going to focus on today. So this project began in 2014 when I was approached by a group in Midtown Manhattan, and the Bernstein real estate family have owned a number of large-scale commercial buildings for many years. And their portfolio includes buildings mostly around the Madison Square Garden area. And they happen to have a series of buildings in which they were able to get a lot, a parking lot that came with the building at the time. And the zoning had recently changed. So there was an opportunity to do a new building there. And of course, with that, since they had all of this commercial background, there was now an opportunity to do a new residential building. And this is a new area, a new field for them. And this is just the lot, the overhead view of that. You can see how similar, this very, very dense urban area. There's a small 7-story building beside our lot, and then another parking lot, which is now a 24-story building. So the geography of the area has already changed from this photograph that I've taken. So we have to remember that this was back in 2014, and this passive as projects were just starting up. And we had already done a number of smaller passive as projects, and talking to these folks, it really seemed like this would be a very unique project to do. So when I met with Alex, he was like, what's the best building I can do? This is going to be a leading building for us. We have to start off with a fantastic building. I don't want to, start off with this and then have a so-so building. And how can I set myself apart? And so I very simply told him, well, you have no choice, but you have to build a passive house building. And of course, at the time, having dealt with this, having looked at examples in Europe, having really, kind of shaken the can a little bit and investigated it thoroughly, I was convinced about the methods that I had seen in different countries. And so the goal here was to say, well, look, you should build a passive house, not just for the energy savings that you're going to see, but for all of the other benefits, the quality of the air because of balanced ventilation and filtered air, the quietness, and the general overall quality that you get from a high performance building. And this was also important for setting a certain standard. So the next thing that I said you need is a modern aesthetic. This is what we do. This is what we're really good at. And we can combine these two things. If you can, try to include some affordable housing. It's really important to try and do that. And there are also tax benefits that are provided to you if you can do that. And in the end, you will get a different product and it will do well. And that's essentially the model that Bernstein Real Estate followed. And the building is almost finished now. It's half occupied, and they're very happy with it so far. So of course, upon obtaining this project, it was really, as I mentioned earlier, it was there weren't really very many other examples of projects of this scale happening. Cornell Tech was in construction at the time, but we were really on the leading edge of this process. And so it was about creating a really good team, and a team of folks who understand passive house. Because my experience with a lot of contractors and developers is that it's a pretty conservative group. And whenever you take on a lot of risk when you're building, right? So starting new ventures, starting new strategies, there's always a lot of a lot of second guessing at that. And I totally understand that. And so part of this was creating a really, really strong team that was going to have or be able to create a successful project. So between the mechanical engineering, the facade consulting, and the contracting, and also the airtightness contractor and owner's reps, they're all very, very important parts of this process. So in that team structure, we were very focused on the architecture, on the zoning, on integrating affordable housing, on doing the interiors for the project and integrating the architecture with the interiors. And of course, as a passive house consultant. So as I'd mentioned earlier, part of the important process for us is to be driving that train, because energy and design should always be integrated together. They should not be separate. And it has been a kind of a back and forth over the years, but we think that it's really important to integrate that process from the very beginning. We all know about the 5 Pacifist Principles. I won't really go into it very much today, just to mention them that they were integrated from the very beginning in terms of heat recovery, ventilation, special passive house windows, very good high-spec insulation, really tight air-sealed envelope, and thermal bridge-free detailing. So looking at the lot again, one of the challenges that the Bernsteins presented to us was, well, how are we going to safeguard all of these lot line windows that are in my office space next door that have all this rental income? And so we developed a number of different schemes with varying zoning envelopes. And what we came up with was a base building that occupied the first floors, half of the building. And then we, instead of doing a 20-story building that went the full width of the site, the site is only 45 feet wide. It's quite narrow. We scaled it back and we went up higher. So we played a little game with the floor area and squeezed it away to be able to create a more exciting shape, but also to safeguard a lot of those windows that were facing west from the offices. And then we added one other feature, which was creating or inviting an artist to come in and paint a mural on that side of the building so that those neighboring offices were looking into something that was going to change. So on the lower floors of the building, we have studios, 1 bedroom and 2 bedrooms, and on the upper floors, a range of 1, 2, and 3 bedrooms. So there are some floors on the upper floors in that tower unit that are full floor. Pretty amazing, amazing units. This is a typical floor plan on the lower part of the building. So you've got the affordable unit there on the lower right-hand corner, really generous size rooms, a studio on the lower left-hand corner, and then a 1-bedroom there. So 4 units in all, and it allowed us to have that variation of typology that, of course, all of these city buildings, rental buildings are looking for. You have to have a variation so that as you bring people in, they feel like they have something for them. Everything, it works for them. In the affordable range, so out of the 55 units, 17 of these units were affordable, and they were spread throughout the building. So there's some very, very lucky people right now who've applied. I think it was many thousands of people applied, and I understand that the folks have been selected now to occupy the building, so that's great. So in terms of our design element and focus on this, so we are really looking at, and our firm is really focused on creating light-filled interiors with a variation and as large a window as we could get. And of course, this is kind of counterproductive, especially if you have a south-facing window. So we designed this special shading system on the outside that I'm going to show in a few minutes that helped us achieve that. Flowing spaces from the kitchens to the other living rooms areas, but always trying to connect to the outside. A little feature, this is the mural. These are the guys who came over from the Netherlands. They did a really cool video. You should check it out on YouTube. And basically it's their process, and they have this video of the whole thing, and they engage how this building is this energy efficient building and how they're going to make their mural part of this portion of the building. So the other element that was really important was the whole entry sequence. We have some really nice materials selected for the lobby area, these really nice wood and stone materials, and creating a really tall ceiling, a double height ceiling. But of course, all of that ceiling height produces a lot of heat gain. So what can we do about that? Well, we created an awning structure. This is it in the design phase. During construction, we made some changes to it, and we brought some of that wood material that was inside to the underneath of this canopy, and we adjusted its shape, and it creates a kind of a dynamic, custom, bespoke awning or entry that's more inviting to people coming over from 7th Avenue. So here we have the design elements, the window shading system on our building. And we have a unique shading device that comes out from the building surface and provides us a reduction in the amount of sunlight that comes in during the summer, but still allows lower winter sun to go into those interiors. Those shading devices are finished with a metallic finish, and they are a counterpoint to the cement board high performance panels that are the rest of the facade system. And what's interesting about them is, depending on the time of the day, the shadows from these devices, and the colors that are in the sky, they reflect onto the materials of the building. So we're really happy with the facade. We're getting a lot of compliments about how this building looks in the street. So with all of these other projects that we've done, a lot of people are asking us, what is the difference between these smaller projects or mid-range projects and these super large 20-story plus buildings? And the changes are quite significant. So I've listed out a few of them, I think 4 or 5 of them, and I'm going to go through them just to talk a little bit about the changes. So first of all, we need to have a different team set up. Normal buildings, you have a certain amount of collaboration. Well, with a passive house envelope, you really need to be doing that much more collaboration early on, because you have to integrate so many more metrics of energy into the equation. If you do that, you're going to have a much more successful projects, and you're going to have a lot less changes during construction. And we don't like changes during construction. Architects don't, developers don't, contractors don't. The second thing is doing a full-scale mock-up. So on a smaller project, you can experiment, you can do your testing on the facade. Well, I would recommend on the larger buildings that you always do a full-scale mock-up. And it's not just for looking at this, it's actually as a training tool for all of the contractors and subcontractors. So here's a photo of all of these folks looking at the details. We'd actually make them do the details themselves, making sure they have it right. And then that was our standard. So then we would go through the building and say, look, you've missed these little areas here. You've got to redo the air barrier. This is the type of extent of work you have to do on these larger buildings. The next big thing was the guarded blower door test. So on these large buildings, you can't, because you have a hoist going up behind the building, you can't do a proper blower door test mid-project because half your building is open. So Stephen Winter did a great job in this project in creating 2 or 3 floors where we did test floors, and we pressurized the floors above and below so we can see how those floors were performing. And they both did well, so we knew that, okay, what we were doing was working well. And this is just a funny photograph of me. I was in the testing floor, and this is the air pressure that's coming from the floors above and below in through the elevator core. And you realize the sort of pressures and how these blower doors, it doesn't lie. I mean, it's going to tell you how much air is coming out from your building. The other thing that was really, really difficult for us is halfway through during construction, we were told we had to do a split TCO. And this was a real problem because, you know, it's one thing to do this on a normal building. It's another thing to do it on a passive house where you have to do a blower door test. So we at first said, well, it's going to be impossible. But we did find, after about 2 months of going back and forth, we did find a way of doing it. And literally the week before people were going to move in, we did a final blower door test, and we got a great number, 0.35. So our understanding is this is the first time this has ever been done. So we're really excited. It's exciting to get a first time that something has been done. And so just reaching further, I wanted to just talk about the buildings of excellence and where we are. When we were in construction, when this was announced, and it seemed like a really great opportunity to submit for this until we found out the requirement that our building had to be 5% better than what we submitted to the DOB. And you have to understand, we had already submitted a really, really good passive house building to the DOB a year and a half before. And here now we had to do 5% more. And we were like, oh my God. So how were we going to do this? So we set about with the team and we modeled some more things, looking at what things we could change, because obviously we were already in construction then. There's only a certain amount of things you can change. And 5% that we needed. We looked at some energy reductions, appliances, different things that we, ventilation requirements. We added PV onto the building too. And so we got down to a very good reduced number overall. So we've ended up with a building that has got a much lower energy requirements than most of these other residential buildings. The one big thing that we can't control are the plug loads, that gray bar there. So that's something that we're going to have to inform the building owners about and see if they can engage in practices that save energy. So just lastly, I just want to talk about the Climate Mobilization Act. This was enacted last year, and it is going to require buildings to monitor their emissions. And over the next couple of years, they're going to be requiring all of these emissions requirements starting in 2024. A lot of the residential buildings are below those requirements, but it's getting more and more stringent in 2030. And in 2035 to 2050, it's even lower. And you can see where this building is. It's below the 2050 limit requirement. So that's pretty amazing. And also good to note that a retrofit of a building can be done as well to these limits. So just in finishing, I just want to say, just given these times that we're in with the COVID realities of how we're having to reinvent ourselves, that we should take the opportunity to look at this and see, well, why can't we build all of these buildings this way? It's at a very small, minor cost increase, and we believe that it's really worth doing. Yeah, so thank you very much to my guests, Victor and Patrick, today, and have a great day. Thank you.